Okay, welcome to the module for week 7 of the class. In this class, we'll start talking about how to use functions in C++, and then in the follow-up video, we'll talk about using the functions for recursion. So what is a function in C++ and what is this use? In reality, we already have a C in a function. It's called the main. But in general, we want to make sure that as we write C++ code, we don't end up having all the code in a single huge page. And often also there is repeated pieces of code that we certainly don't want to do cut and paste as a way of doing repetition. And there are many reasons to avoid this. One is really just have clean, readable code. Secondarily, also, when you use the same code in different places, the code may have a bug, and then once you fix the bug in one place, if you did some kind of cut and paste, it will be very hard to chase the other locations where that particular part of the code has been fixed or not. So general functions allow to create a set of blocks of code that you can call with a meaningful name, and so it makes the code more readable, more abstract, in some sense readable by human. And also in a function there is a mechanism where memory is allocated and released for local variables, and that actually it's very convenient so that those don't get stored all the way throughout the execution. This leads to the use of an area of memory called the stack, and there are two types of memory, the stack and the heap. We'll have a more detailed discussion about those in the future. But it's important to know that everything inside of a function is self-contained, and the compiler automatically allocate and deallocate memory so that the user doesn't have to do it, the programmer doesn't have to do it. So in simple term, a function it's very similar to the mathematical concept of a function. So if I have a mathematical function like this, say my function is 2 plus x squared, we can write that in C++ with the following syntax. First of all, we declare the function. So the function takes an input, a variable x that we declare to be of type double. So it's a double precision floating point number, and will return a double. So from the mathematical perspective, it's similar to the mathematical function that you take an argument and you do some calculation and return a value. Obviously, the idea of doing some calculation, it's generalized in C++, can be anything, and the fact that you take an argument and return a value, those are all optional. In this case, for example, the C++ version of this expression is again 2 plus x times x, and there is the return statement that says this is the value returned by the function itself. So let me look at how to do this in practice, and I have just a couple of very simple examples. It's always kind of better to see things in action in practice. So this is kind of the simplest program you can write, typically the first one. So now you start looking at how the main is a function of type integer. It takes no arguments, and then the body of the execution is run, and then actually the integer really tells the operating system if the execution ended with error code or not. So here one can compile and execute. You have hello world, and here you see exited with code 0. So 0 means no error, And so this actually not only got executed, I get to the end, there was no error. So the main is just a function that the operating system call when execute a program, and the return value is the potential error code of the program. Now let's see how to make this code a little bit better by replacing the print statement with a function. So I'm just cut and pasting to be a little bit faster. So let's say that we have a hello world print statement that we want to make with a parameter x. So we'll actually add the number somewhere here. And so we have a void, means it's a function in this case does not return any value. So first of all, so we define this function. Let's say we build it, everything works. So let's now use it. And let's say that now we want to do hello world and we write the number 0. So it would be hello world 0. So the function I created here is being called here. So again, let's build again the solution, then I run it. And now we have the original hello world and then hello world 0, which is what I just executed. So now this has been generalized. I can do it a few times, and I can do hello world 1 and 2. Let's see the execution. And so this is executed multiple times. So you see that now instead of cut and pasting the code, we are able to just call the function. So practically this means what? That if I were copying this multiple times and now I want to translate this, say in Italian, and it's called Ciao Mondo, I now edit the code only once instead of 3 times, right? While if I were to do it in this code, I would have to copy again and again, right? And so here now, you see here I had to do it once. If I were having multiple print statement, it would have been multiple times. So now I copy, execute, and you see now Ciao Mondo is the one that I added in the main. This is executed 3 times, but the code is written only once, and I could modify that only once. So let's go to the example of the mathematical function that we saw in the slides. So here is my function, double x. So it takes a value x in input and will return a double in at the end of the execution, and it will return 2 plus x times x. And so here I could do another print statement, and I do the mathematical calculation inside the parentheses. So again, instead of start complicating this more and more with a function in there, I could now put the function in there, execute it, and you see now Ciao Mondo 6, this is the hello world. So maybe we can go back to, say, hello world. And so I can execute it again, and we go back to the hello world 1, 2, 6. Interestingly, so when I build, let me show you also some of the potential pitfalls. Let me rebuild the solution. Oh, notice now there is actually a warning. So the argument is converted from double to integer, so there is a possible loss of data. So here the compiler, and that's why we recommend to keep, that we require for the class to keep a high level of warning. So function returns a double, but the hello world takes an integer. So this means here there is a conversion of type that happens kind of automatically, so the compiler give a warning, this may be a problem. So to indicate to the compiler that I know what I'm doing, I can use the function int that convert a number into an integer. And so now I can clean the solution, build it again, and you see the error goes away. And so here I show the intentionality adding with this layer of a function, and then I compute this number, I convert it into integer, and then I'll print it. And of course, execution gives the same value. Obviously, here we can use the function itself inside the function, and so the value will be returned again. And so here you see hello world 38, and so we have here you can see 2, they get a 6, and 6 squared plus 2 is 38. So here, just to give a sense of how to use the functions. And to close, there is an important distinction between declarations of a function and definition of a function. At the moment, I went directly to definition. It is very common. But when we want to break up the code, potentially multiple files and so on, it's important to do the distinction between the two. The declaration really declares only the structure of the function call, right? What is the input and what is the output. The definition actually takes the whole, in addition to the declaration, actually it says what the function is going to do. So for example, here I could add between, so before the hello world, the corresponding declaration, you see void hello world int x semicolon. And then I could do the same for the function. Actually, let's not do it for now. So what happens here now, this is declared and this is defined. So let me clean the solution and recompile. Oops. And see here there is no error. No, what I can do now, so what's important is that the declaration has to be given before the use of the function itself, because the compiler needs to know what are the inputs and outputs. But I can move now the definition after it's being used. So the compiler goes through the code. For the hello world, it knows only how it's being called, but there is no information regarding the actual content. The function will be defined later. So I can clean and build, and still there is no error. I can run and I get the same results. If I were to move the function, the mathematical function under, so now there is no declaration. So what I would expect now is that if I clean and build, you see my function is not defined, and it happened twice, because here I'm calling the function twice, but the function has not been declared yet. So what I can do is I can take the declaration part and I put it before the main. At this point, those two functions are declared. I can clean the solution, build it again, and you see now things are compiled and work just fine. In fact, the difference between those two is very important. So for example, I can have multiple declarations on one of the functions. That creates no problem. I can clean and build. Nothing really changes. But if I were to create two definitions now, and they have the same input and output, now the system, if I clean and rebuild, is going to give me an error. The function already exists, and so we cannot do it twice. So it's important to know that definitions are uniques, and declarations, as long as they are compatible with each other, they can be multiple. And we'll see later how important it is, especially if we divide the code in multiple files. effectively I could put this part of the code in a separate file and only have the declaration. That would be enough for this code to work. So anyway, let me clean it up, go back to a single declaration. It works, but it would not be good style to do that. Build, execute, and so on. And this concludes kind of the basic introduction to functions and their use in C++.